Hello everyone, I am going to be doing an FRQ walkthrough of this question. It looks like this is a question number 2 from an old AP test. And I'm just going to be going through it, talking about my thoughts as I'm doing it, how I think about it, what I'm going to write, and all of that jazz. So let's get started. A manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing to the current method. The appearance of the boots is not changed by either method. That's good. That's good. If it's not changed, it's going to be easier to basically blind it if we need to blind it. Because you always want to control variables, so the fact that they're looking the same is going to be very helpful in this experiment. Anyways, the company recruits 100 volunteers. Let me go ahead and highlight that. 100 volunteers where it rains frequently. That's good if you're wearing rain boots. So it rains frequently to wear the boots as they normally would for 6 months. At the end of 6 months, the boots will be returned to the company to be evaluated for water damage. So it's going to be evaluated for water damage at the end of 6 months. Okay. Describe a design for this experiment that uses the 100 volunteers. Include a few sentences on how it will be implemented. Okay. So when it comes to designs, there were 3 types of designs we dealt with. There was the completely randomized. Was the first one we talked about. Completely randomized just means you have the 100 people and you completely randomly put them into whether they're getting these, the special boots or the old boots. There was block design. Block design was where if you know that there is some kind of subgroup that is going to affect basically the boots in this case, how they're going to be treated, then you would want to block it. And then there was the pair design. The match pair design, my bad. Match pair design, which was to say that each individual does both treatments but in different orders or something like that. So those are the 3 we have to choose between. We were talking about people getting boots. So I think blocking's like already the first one that I'm going to get rid of, because I can't see some kind of subgroup where they're going to, like, you would want these people to get some boots that are the new ones and some to get the old ones. I don't think any kind of demographic is really something you're going to need to split them up for before you do this experiment. It's not like, women are going to go out into the rain more than men. You're not going to say anything like that. So it's between completely randomized and matched pair. Completely randomized, I don't think I like that one, because when you go with completely randomized, you always try to pretend worst case scenario is going to happen, because people are wearing these boots. And as you know, some people go out into the weather more than others. Some people work at home, some people have to travel a long way, so they're going to be taking a train or a taxi. Some people are going to walk down the streets. So different people are going to be outside using these boots more often than others. And if you do it completely randomized, then it's possible you'll accidentally get a group of people that go out into the rain more. So that doesn't seem very good to me. So it's probably going to be matched pair. So I'll see if that makes sense to me. In a matched pair, that means every person would wear both types of boots. So you'd be able to compare. A single person is wearing both boots, and then you could compare the boots. That seems like it's going to be okay to me, because then you don't have to compare one person's situation with another person's situation. It's literally each individual person's situation is going to be the same, and you can match their boots. There's 2 ways I can think about doing a match pair. One is they get a pair of boots, and then they send them in, and then getting the other set of boots, and they wear those. But I don't think we can do that one. because it specifically is saying that at the end of 6 months, they're going to evaluate for water damage. So they don't really have time to like, oh, for 3 months you'll wear these boots, and then 3 months you'll wear those boots. And then you send them both, and they're not going to do that, which means you have to give them a set of boots, and they have to wear both, which means I guess we're going to have to separate it into like a left foot and a right foot. Since, you know, boots, you have to have two anyway. You can make like one of the boots the new version and one of the boots the old version, and each of them, then each person, you know, has both the quote unquote the control as well as the new treatment. So we'll go with that. We're going to go with match pair, and we'll give each person one of each boots. So describe a design for this experiment. Now, I'm going to write something that isn't a good replacement for an answer, but it is something that usually gets you at least a partial credit, and that is to actually do the matched pair diagram. If you remember from class, we had the experimental units, and then what you do is you randomly put them into either treatment 1 or treatment 2, and then treatment 2 or treatment 1 afterwards. In this case, it would just be both of them. If you wanted, you could change it from left foot, right foot, and right foot, left foot. And then these people would just be the right foot, left foot. But honestly, I think that's probably a little too much. You would just go into, they're randomly put into, you know, actually, I don't even think it matters for this one. So we're actually not going to do that at all. Boop-a-doop-a-doo. Yeah, I started making it. It doesn't seem to make sense, so I'm going to cross it out. That's what you do on AP tests. So if you saw match pair and you started doing this, and it doesn't make as much sense because they're going to be getting one of each type of shoe, just cross it out, and then you go back to it. What we're actually going to be doing is the experimental units, and everyone's going to be getting the same type of treatment. And that is one boot of each. We are going to have to say which one is left and which one is right. So when we're writing our paragraph, we'll just say it. Describe a design for this experiment that uses 100 volunteers. Okay, so let's get started. So the first thing we'll talk about is every single volunteer getting one boot as the new method. Where is it? The current method. And new method, there it is. Okay. So describe it. Send each of the, let's see, what is it, 50? Well, the reason I'm saying 50 is because of the whole left foot, right foot. You do still want to randomize that part. You want to give half of them left, and then the right is like, sorry, I just realized I'm off the page. Like in the first group, you would have the left foot being the new and the right foot being the old. And then in the second group, you would have the left being the old and the right being the new. The reason you would need to do that is because most people are right-handed, which means they might use their right foot more for stuff, I don't know. But you would want to, just in case, you know, one leg is favored more than the other, then one boot would be favored more than another. So just to cover the bases, you do want to kind of do that as well. So I'm going to say 50 people are here. And I'm saying send each of the 50 people. That's not good enough because I didn't use randomize. We are supposed to randomly put these into groups. So send, let's just start over again. So randomly select 50 individuals to receive a pair of boots where the left boot is the new method and the right boot is the old method. The remaining 50 will receive the left boot as the old method and right boot new method. Okay, so 50 of them will have it left and right, the other 50 will have right and left. And then describe a design for the experiment that uses all of them, how it would be implemented. So at the end of 6 months, the boots are sent back, analyzed, and compared for water damage. Okay, so that should be a good enough answer for here. If I was to be, eventually later grading this, the big things I would probably need to look for is once again the word randomly. You have to randomly assign things, so it is important to use that word. Randomly assign 50 of them to receive a pair of boots where the left is new and the other one is the old method. So something about that, something about you using a matched pair. I wrote it over here. I'm describing it as a matched pair over here. So either one of those is fine. I could look here to get the credit. I could look over here just to see the fact that you are doing, in fact, the left boot is the new method and that one's the old method. And then of course, eventually what you're gonna do with at the end. So those are the things I would look for when I was grading it. Part B, it says, could your design be double blind? Not only could it should. Because, as a person, if you know one is done as a new version and another one's the old version, then it is possible you'll psychosomatically start thinking that one boot is better than the other. And when it comes to rain boots, if you think your left boot is better than your right boot, you're probably going to use it to step in puddles more often than the other. Because you're like, oh, this one's more waterproof. So if I have to step in a puddle, I'm gonna, use that one a bit more because I want to keep my foot dry. So you definitely do not want the people to know which one is the new one and which one's the old one. So you definitely have to blind it. The reason you have to double blind it is because of this part in purple up here, evaluated for water damage. Now, a machine cannot evaluate water damage for you. This has to be done by a person, and it is very subjective if you are looking for water damage. You'd have to see if there's something on the outside, on the inside, what's happening to any of the fabrics or rubber, whatever they're using, but it is a person looking at it. And if a person knows that this is the new method and this is the old method, they might say, hey, even if they have the exact same water damage, then, hey, I think this one's actually better. Just because, once again, psychosomatically, they're just thinking it. It seems to be an opinion. So you do want to double blind it. So could you double blind it? First of all, we're going to write the word yes. Yes, we are. Don't just go into an explanation, but in fact, write the word yes. Explain. You don't want the experimental units or individuals, whichever, to know which boot is which because it could bias, I don't know, their use of the boot. Basically, just make sure you are saying something where it is obvious that you know what blinding is and that it would somehow reduce bias. There's many ways you can do that, but you got to write something about it. That's it about blinding. For the double blind part, you also want the analyzer to be blinded so they can't accidentally or purposefully bias the evaluation of water damage. And if you really wanted to go on to say more, you could just, add a paranoia, knowing which one is new, they might evaluate it better, I guess. Evaluate than it deserves. Something like that. Just any old thing. It doesn't have to be specifically anything like this. Grading it, first of all, you have to say yes. If you say no, it's going to be incorrect. The only way you could say no on this and get credit is if you got this wrong. If you got this wrong, then I have to grade this based on that. So if you wrote something here that could not be blinded, then you have to say no here. It has to be consistent. But if you get this right, then you have to say yes. If you don't say yes, that's peer lower. You don't want the experimental units to know which boot it is because of bias. So don't want to know because of bias, and then you say some way that it could be biased. Also you also want the analyzer to be blinded, and then some reason, whatever reason. It could be the green reason, it could be the blue reason I did down here, but some kind of reason. Can't accidentally bias. Okay, that's it. Once you got those things down, you should be fine. Pretty sure there's not a back to this. There is not. So, like I said, those are Mr. Anderson's feelings and thoughts. It is how I think when I'm doing through these things. So, as you can see, there is scratch work. It is fine to think things through and then go back and change your answer. I know a lot of you guys, when you do your papers, I see this on the side as well. And just know that that is fine. If you have lots of thoughts, just try to go through and knock off things that don't make sense. And eventually you'll come up with the stuff that does. Okay, that's it. Hopefully this was useful. Have a good one.